Okay, so I am here in a brand new project. I'm actually running this in the alpha version of Unity, which at the time of recording is Unity 2020.1. Now, the first thing I want to do in this project is actually switch over to Android build settings because that's how we're going to be building our games, and I just want to sort of build these Unity core classes up from that foundation. I think that'll make things easier as we go throughout the year developing some of these games. So I'm going to go ahead and let this finish building out so that we'll be ready in the Android build settings on this alpha version of Unity. All right, so it looks like we're loaded up there. I'll just make sure I'm in the correct screen size, and I'm in this 18:9 portrait mode. If you guys want to follow along in that mode with me, you're more than welcome to. So in this tutorial, we're going to be covering menu management, and that's going to involve a couple different classes working together. Now, first, it'll be important to define the problem. And here's the problem that we're facing with menus. Unity doesn't give us any native way to switch between different UI elements. So we need to come up with a way to define pages, which are controlled by a page controller. So our system is going to provide definitions for different page types, such as loading or main menu or options. So we'll have different enumerations for those page types. Our page controller is going to allow us to turn certain pages on or off. And so that's the problem that we have to solve. And what it's going to involve is an enumeration for different page types, a controller class to control the pages, and the individual page class, which is going to go on each one of those pages. Now, we also want to be able to animate these pages. That's going to be very useful for customization down the road. Now, with those requirements sort of laid out in front of us, sometimes the best way to start a new system is by defining the test class. So we want to go ahead and create a test class for our menu system. Okay, so I'm going to go ahead and create a new folder for scripts, and inside scripts, I'll call these core classes. I'll put these core classes in a folder called Unity Core. And the system that we're working on today is called menus. So that will be in our menus folder. Now, as we go on with this series, this will be the directory where we lay out all of our core systems, as I mentioned in the beginning of this video. Some other ones would be data, audio, scenes, and any other core systems that we would like to utilize in each one of our projects going forward. So the first script that we want to create is the testing script, because the testing script is going to lay out the functions, the main functions that we need to test for the system to prove that it's going to work. For example, the ability to turn pages on and off. So I'm going to create a new script here called test menu, and then we're going to go ahead and open that up. Okay, so here we are in our test menu script. I'm using Visual Studio Code, but you're welcome to use whatever code editor that you want. I'm going to go ahead and clean things up a bit so that we're only using the items that we know that we need. I'm going to place this in a namespace called Unity Core and Menus. So we're going to call this Unity Core. And it'll also be in the subset namespace called Menu. And this is just for code organization. This will help us organize our systems as we drop this Unity Core class into our future projects. It'll start to look a lot more organized in the context of larger systems or projects. Okay, so test menu. So what we're going to do is actually say, hey, we only want to run these tests if we're in the Unity editor. And that's what this preprocessor if conditional is going to do for us. So anything within this preprocessor definition is going to only run in the Unity editor. The reason why we do this is because we're going to end up putting this test class on a Unity object, and we don't want to have any of this code run in the event that we forget to take it off before we build the game, if that makes sense. So inside here, we're going to have an update function that will run when we run the game. And inside here, we'll have several inputs that we want to press in order to test our menu functions. So for instance, let's say we press the input key code F. So if we press F, we want to test a specific function in the menu. So this would look something like, well, we'll have a page controller class. So at the top of this, let's create a public reference to our page controller, since we will be adding that reference later. So that's going to look like this. So we'll have this page controller that we're testing, and we want to test the ability to turn a page on. So we'll say page controller, turn page on, and keep in mind that this function does not exist yet. It's one that we want to create. Okay. Now, we can't just say turn page on, because we don't really, the page controller isn't going to know which page to turn on. So this really needs to be parameterized. And the parameter that we would pass in would be some sort of enumeration called page type. And let's just say we want to turn on the loading page. So recognize that this has not been created yet. We're going to create that in just a moment. Okay, so we also want the ability to turn pages off with this system. So not only do we want to turn pages on, but we want to be able to turn them off. So we'll do the same exact call on the same exact enumeration, except we'll be turning that page off. And we want to change the button that we press to test this. So we can use G. So we'll be using F and G to test the on and off functions. Okay, so let's go ahead and create some of these variable types. So we'll go ahead and create the page controller class and the page type enumeration. Let's go back to Unity and set that stuff up. Of course, when we come back to Unity, we'll see some errors because those definitions have not been created yet. So we'll create a new C# script called page controller. And then we'll create another C# script called page type. Now let's head back to the editor to fill in these definitions. Okay, so let's start off with page controller. So page controller, we just want to get rid of these errors. So we're going to put the page controller in the same namespace as the test menu object. So that's going to be namespace Unity core and namespace menu. Okay, so that definition is created. We also actually need the turn page on and turn page off functions, so we can go ahead and create those as well. And what I want to do is just create regions around these functions so it helps keep the code nice and organized. So we'll create a region for public functions, and then we'll end the region here, and then everything inside this region should be publicly accessible. So we'll create a public void turn page on that accepts a page type. Okay, and then we'll also create a public void turn page off that will also accept a page type, just like that. Okay, so that should handle all of the definitions in our test menu so far for page controller. We also need to create the page type. So let's go over to the page type class here. Again, we want to make sure that our page type is in the correct namespace, but also since this is just going to be an enumeration, we don't need any of this right here. So we'll go ahead and create the namespace for Unity core and the namespace for menu. And then inside of the namespace for menu here, we're going to create the public enumeration called page type. Now, normally with enumerations, I'll go ahead and create the default value for none. And that's just in case we want to represent some sort of null state for the enumeration. Not required, but from my experience, that has been pretty helpful. And so far, we're only using the loading page type. So we'll come back as we add new pages and fill in the page type here. That'll generally vary from project to project, so don't worry too much about that. Now, if we go back to Unity, we should have cleared up our errors, and we are well on our way to scripting out the page controller class. Okay, so we're back in our test menu script, and we just want to make sure that we're considering all of the requirements that we want to hit. Now, we have the ability currently to turn pages on and turn pages off, but we also might want the ability to turn a page on after turning another page off. For instance, if you can think about having a loading screen go to a menu screen, you might want the ability to turn the loading screen all the way off before turning the menu screen on. Alternatively, you could have the loading page fade out or animate out at the exact same time that the menu screen fades in. So there's a lot to think about when it comes to this menu system, but regardless, all this means is we also want the ability to have control over how pages get replaced by other pages. So let's create another test case here where we check the input for, let's do H. We'll just go across the keyboard. And in this test, we want the ability to turn a page off and then turn a page on with the same call. So we want to be able to say, let's say turn page off, page type dot loading. So we want to turn the loading page off, and then afterwards we want to turn on the menu. But then let's say that this function call is our sort of synchronous call or our asynchronous call, where the loading page must be completely animated off of the screen before the menu starts to animate in. But then we also want to have the ability to make those transitions happen at the exact same time. So we also want to be able to say the loading page can optionally start to animate out as the menu animates in. So we want those two things to happen at the same time. So we'll create another test case here, and instead of H, we'll use J, and here we'll add a third parameter, and we'll call this true. So this true would signify that we want these two to animate out and in at the same time. And in this call, maybe we want the ability for the loading page to be completely out of the screen before the menu comes in. And with these 4 test cases, we will have a fairly robust system. So you'll notice that we're using the same function name here. This indicates that we would have 2 optional parameters because this function call is not using the last 2 parameters. That would indicate that this parameter and this parameter are both optional. So we'll have a parameter, a second parameter that's a page type, which is optional, and the third parameter, which is a Boolean, which is optional. So let's go back to our page controller. And let's go ahead and add some optional parameters here. So since we're using multiple page types, this might not be the best name for this function. Instead, we will say that this is the off parameter. Then we'll have an optional on parameter, which since this is an optional parameter, we'll have to assign a default value to this. We'll call this none. And then we'll have an optional Boolean, which is called wait for exit. And then that will be initialized to false. Okay, so we do want to recap what this exactly means. So we'll have the ability to optionally provide an on parameter, which would occur after the page off is actually turned off. This wait for exit parameter is a control parameter that would allow us to determine how these two pages turn off and on and what that relationship looks like. Okay, so we'll actually provide some examples so that this is much easier to understand as we start to build this out. Okay, now I think we added a new page type. We called this menu, so we'll go ahead and add that page type in right now. And then if we go back to Unity, we would hope to not see any errors. Okay, so no errors yet. So let's go ahead and continue building out the page controller so that we can meet some of the requirements in our test script. Okay, so now I just want to go through and sort of skeleton this class out so that we can understand all of the requirements that will be involved in this page controller. Remember, the page controller is a controller of pages. So think about it like the manager, which is in charge of making sure all the pages work together seamlessly. Now, we can optionally make this a singleton object so that it is the only page controller that exists. That's up to you guys. For me, with a class like this, I do like to make it a singleton, so I'm going to create a static instance to the page controller like this, and then we'll make sure that there's only one page controller out there that controls all of the pages in our app. Okay, now since this is a core system, I'm going to provide a Boolean called debug, make that public so that I can choose whether or not I want logging on this system. That tends to be very useful whenever you're testing new systems. Then we'll go ahead and create a public page type for an entry page. So in case we want to have a page that loads up at the very beginning of the game, we would define that here in the entry page. Okay. Now we'll also have an array of pages, which hasn't been created yet. This page type has not been created yet, but the page is going to represent the actual UI objects in the Unity hierarchy. And what we'll end up doing, since this is a public variable, is dragging those UI pages that we create in Unity, and we'll be dragging those into this pages array so that the page controller will always have context for the pages that exist. Okay, the last variable that we're going to use in the page controller system is going to be a hash table of the pages, and this hash is going to represent the relationship between page types and pages. For instance, we might have a page, a loading page, and this hash table is going to utilize the relationship between the page type and that physical page in the object hierarchy. That way it makes it very easy for us to locate certain pages just using the page type. As you can see here in these two functions, we're only passing the page type enumeration, which is very fast. Inside the function, what we'll end up doing is using the page hash to locate the actual page object, which again is going to represent the actual UI element in the object hierarchy. This is much faster than simply iterating over a list, and actually it's a lot easier to manage and work with from a coding point of view. Okay, let's go ahead and continue on. We're going to have a region for Unity functions, and inside this region is where we're going to specify our singleton, which will be in the awake function. So we'll go ahead and create that awake function down here. Now we're also going to have some private functions that will help us maintain some of these data structures that we've defined up here as the public functions are called by the end user. Okay, so we'll have a region for private functions, and any private function that we have in the system should be placed inside of this region. Okay, so when it comes to private functions for systems, I tend to create the logging functions first. So we'll go ahead and create a function called log, and then we'll pass a message into that. We'll also have a log warning. And if you want, you can go ahead and create another function called log error. Although usually if there's anything wrong with the system, I usually just pass it into the log warning function. But of course, if you want to, you can use the a third function called log error. Okay, now we're also going to want the ability to grab pages using our page hash. So we'll create a separate function for that so that we don't have to worry about doing that in all of the functions. We can simply use a private function to handle any sort of error handling involved with that process. So we'll have a function that returns a page that will be called getPage, and the parameter for this function would of course be a type, because we get pages based on types thanks to our hash table. Okay. Now, along with getPage, we want the ability to sort of register pages. So at the very beginning, we're going to be taking the pages inside this public page array and building out the hash table for the relationships between the page type and the pages. So we'll create a function called register page to handle that for us. Register page, and of course that's going to take the actual page object. Okay, and then we'll go ahead and just create another helper function for register all pages. That way we don't have to write whatever code goes in this function into the awake function. We can simply call this in the awake function. Okay, and that just sort of cleans things up in our awake function. And sometimes it's good to separate out the logic, because when you look at a skeleton like this, you pretty much understand exactly what the system is intended to do. Okay, now we'll also want to see if a page exists periodically throughout the system's functions. So we'll create a function that returns a Boolean to check if a page exists. That's going to be looking through the page hash. Okay. And finally, we'll actually have an IEnumerator function, which is going to wait for page exit before turning on another page in the event that wait for exit is true inside this TurnPage Off. Okay, so I'm going to, after I'm done with the skeleton, we're going to hit each one of these functions one by one. So don't worry if any of this looks a little bit daunting or confusing. We are going to go through step by step each one of these functions to make sure that everyone watching this completely understands how this system works. Okay, so we're going to have this coroutine, which returns an IEnumerator, wait for page exit. And if you don't understand coroutines, I will go over this before we implement the actual coroutine. But basically, this coroutine is going to accept an on page and an off page. And what it's going to be responsible for doing is waiting for the on page to be finished turning on. Or I'm sorry, waiting for the off page to be finished turning off before turning the on page on. So that's why we call this wait for page exit. And it's an IEnumerator because with IEnumerators, we have the ability to wait. So even though our code is asynchronous, we have the ability to sort of start up this artificial thread, which runs while the game is updating, and wait for a few seconds for stuff to happen, basically. But I will go through each one of these functions, as I said, step by step, so that we understand everything that's going on. So because we're using the IEnumerator, we need to be using systems.collections. Our hash table also happens to be in the system.collections, but because we're using an array, we want to use systems.collections.generic, and that should cover all of our using statements. Now we have some return functions here. We just want to make sure that we're returning something so that Unity doesn't give us an error. Here we have a Boolean to return, so we'll return false by default. And here we are returning the IEnumerator, which could just be a yield. So we'll return null. And that should cover up all of our errors. Of course, we have this page object that we must create. So we'll go ahead and do that now. Okay, it looks like we have an error on our using statement. It says that it's trying to use systems, but that should be system. So we'll go ahead and fix that in just a second. Let's go ahead and create our script called page. And this will be the last script that we need to create for the system. So we're done creating scripts for this tutorial. Of course, we still have to write out the logic. So of course, this will be inside of the namespace called Unity Core and menu, just to keep everything in the system organized. Again, we're going to clean up some of these default using statements, and I'm going to come back to page controller and fix the typos on these using statements. Let's go back to Unity to make sure that we don't have any errors. Okay, and everything looks good. So now we are ready to jump back into our code, and let's go ahead and create the skeleton for the page class. Okay, so remember, the page controller controls multiple pages. The page controller also tells pages to turn off or on. Now, it's the page's responsibility to actually trigger the animation or handle any sort of other state logic. So we're actually going to use some flags, which will just be some static strings. We could create an enumeration for this as well. However, I'm going to go ahead and make these read-only strings so they can't be modified. They are similar to enumerations, but it's just a different option that we can choose. So we want to define the states. So the states might be turning on, turning off, or resting. And we'll actually end up using these states in an actual animator controller whenever we're actually building some simple animations for these pages. So let's go ahead and create a public static read-only string called flag on, and that'll just be a string value. And the reason this is public is because the page controller may need to check the state of a page. So we might be trying to see if a page is turning on from the page controller, or if it's resting, or if it's turning off. That sort of information can be useful in a format that is read-only. So we'll also have a public static read-only string for flag off, and a public static read-only string for flag rest or none. We can call that none. Okay, and again, if you want to, you can create an enumeration, and the logic will be exactly the same. Okay, now with these flags, we'll actually have a string called target state. That'll be a public property that is public to read but private to set. So we can go ahead and create that like this. We would have a public string target state, and then we'll say that can be publicly gotten but privately set. And this is sort of a shorthand notation for properties in C#. Of course, while we're creating public members for the page, we want a public page type to be set from the inspector. So we'll create a public page type. We'll just call that type. And we also want to have control over whether or not we should use animation. So as we're flipping pages on and off, we might just want that page to turn off immediately and turn on immediately, or we might want it to have a fancy animation associated with it. So to set that control, we can create a bool called use animation, and the default will be false for that member. So in the event that we use the animation, we want a reference to an animator. So we'll create a private animator called animator. And at this point, we can start skeleting out the functions. So we'll have a region for Unity functions. We'll just have the Unity function awake, or maybe on enable for this. And what we're going to end up doing in this function is checking to see whether or not we need a reference to the animator. And if we do, then we actually set the value for that animator. Okay, and then we'll have a region for public functions, which are likely going to be accessed by the page controller. And then of course we'll have a region for private functions, which again should only be utilized within this class, this page class. Okay, so for public functions, what do we have? Well, we only need to tell the page whether or not it should be turning off or on. So let's just create a function called animate, and then we'll use a Boolean to control whether or not this should be turning off or on. So we can just call this Boolean on, and then inside this function we'll create some logic to say if on is true, then we'll turn on. If on is false, then we'll turn off. And that should be all that we need for public functions. Okay, so for private functions, we'll need to have the ability to change state, and if we're animating, we need the ability to wait for an animation to finish before setting the state to none or off or on. So this function, this coroutine that we'll create is going to be responsible for modifying the state over time. So we'll create a coroutine called await animation, and then that will accept a Boolean to determine whether or not we're turning on or off. And since this is returning in IEnumerator, we'll yield to make sure we don't get any errors from Unity. Okay, and then we'll also have a private function for checking whether or not we need the animator reference. So we'll have a function called check animator integrity, and this is going to be the function that gets called in on enable. Okay, and then we'll just have some of these simple logging functions. So we'll have log and log warning. Again, if you want to create the log error function, you're welcome to do that. It's purely up to your style. And for this class, I think we're done. I think that's all of the work that we need to do for the skeleton. And what we'll be doing is running through, we'll probably be going back and forth between the page controller and the page as we're testing some of the logic. So let's go ahead and start off in the page controller to see what we need to do in awake, and then we'll sort of work our way down. Okay, so first let's go ahead and go back to Unity and make sure we don't have any errors before we start coding everything up. Okay, and it looks like we forgot to add the using statement in our page class, so let's go back and add that really quick. Okay, so because we're using the IEnumerator, we want to add using system.collections. That's going to give us the ability to use coroutines in Unity. And I actually just noticed that I misspelled this function, so let's go ahead and fix that really quick. We actually want this to be await animation. And we'll go ahead and check for any other spelling mistakes here. Everything looks good. So we'll go back to the page controller. Now that we know that there aren't any scripting errors and Unity's not going to scream at us, we can go ahead and start scripting out these classes. So we can start off by building out the Singleton for our page controller, and that's going to be really simple. We're not going to worry about handling any sort of any sort of destruction of the object, or we're not going to use the don't destroy on load. We can save that for a separate class if we want to. So all we're going to do for this Singleton is say if the instance does not exist, then we will create it. So that kind of looks like this. So if not instance, then initialize the instance. So we can say instance equals this. And then below this would be any other sort of configurable code or any sort of initialization. So one of the other things that we need to do is initialize our page hash. So that's going to be our pages object, and we could set that to a new hash table. The other thing that we need to do is actually register our pages. So we only need to do this once, and this is a function that's down here a little bit that we haven't implemented yet, but we're going to. So we can call that here because that's configuration code. And then of course we have the entry page that we want to turn on, but we only want to turn on the entry page if it's not equal to none. Remember our page types here, we have none, loading, and menu, and then whatever other pages we might have below that. Now this none object is like our null for the enumeration. So what we want to say is if entry page is not equal to page type dot none, then we want to turn that page on. Okay, and that's all we need to do for our singleton. Again, what we've done is check to see if it's been initialized yet, and if it has not been, then we initialize it. Okay, we're just going to work our way down here, and we're going to implement the TurnPage On function. And the first thing that we're going to do for these two functions is check to see if the page type is equal to none or not. So we can say if type equals page type dot none, then we're just not going to do any processing. We're just going to return. The next thing we want to do is say, well, if the page does not exist, in other words, if the page type that comes into this function is not actually registered through our register all pages function, then we will also want to return. And then we also want to log a warning for that as well. We want to let the developer know that that the page that they're trying to turn on was not found. So we can say if not page exists type. Okay, and what this means again is that the page that somebody is trying to turn on has not been registered. So here we want to log the warning. You can use your own language here in the warning, and then we want to return so we don't continue trying to process something that doesn't exist. So what I'm going to say here in the warning is you are trying to turn a page on, and then I'll go ahead and put that actual page type in brackets. You're trying to turn a page on that has not been registered. Okay, and that's just some useful language for the developer in case they make a mistake. Okay, and now everything below this logic is going to be the actual logic to turn the page on. So what we want to do is grab the page by using our getPage function. Remember that is a function that we added down here in our skeleton. So we want to get the page, then we want to, and I'd like to reiterate, at this point we know that the page is a good value because we've done two things. We've confirmed that it's not the none type. We've also confirmed here that we've actually successfully registered the page. So at this point, we don't have to do any more checks on this value. We know that this is a good value. Okay, so after we have the page, we just want to say, first of all, the game object for that page, the game object associated with that page should be set to active. Okay, because what is actually going to be set up in the object hierarchy is a bunch of inactive UI objects referencing those pages. And whenever we want to turn a page on, the first thing we need to do is actually activate that object. Okay, the next thing we want to do is call page.animate. Remember, that's a function in our page class that we just created. Now, we haven't actually created, or we haven't actually implemented the animate function in the page class yet, but what this will do is if the page has elected to use animation, it'll use the animator to run the animation. If it has not elected to use animation, all it will do on the pages side, on the actual class here, is actually well, nothing actually. And at this point, since we're turning the page on, since we've already set the game object to active, this will actually be a no op or a no operation if use animation is not set to true. If use animation is set to true, then the page will be responsible for actually animating that object. But other than this, this is all of the logic that we need for turning the page on. Now, before we go on, I do want to implement some of the things that we used here. The PageExist function needs to be implemented, and the getPage function needs to be implemented. Also, the animate function in our page class needs to be implemented. So let's go ahead and implement those so that we know that this function is absolutely finished. Okay. Since we implemented, or since we called register all pages up here, we'll want to go ahead and implement that as well. So let's go down to some of our private functions here and finish out some of the assistive logic that we've been using. So we can start off with the register page. Now, when we register all pages, what we'll do is we'll just loop through each one of our pages that are in our public array of pages here. So the public member that we use, that we drag our pages into from the Unity inspector, we're going to iterate through those. So that's going to look like this. For each page in pages, all we do is say register page and then pass in that page into that function. Now the register page function, the first thing that's going to do is check to see if that page exists, if that page type exists. So we can say if the page already exists, and remember what that means is page.type. What that means is if we've already registered this object, then we want to go ahead and notify the developer that they are trying to register an object that's already been registered. So here we can log that warning. And again, you can use whatever language that you want here. And then we'll want to return so that we don't accidentally register that object twice. So what I'm going to say here is you are trying to register a page, page.type, that has already been registered. And then what I'll do to help the developer is give them the game object name, just so they know that they're trying to register that twice. Okay, now if the page has not been registered yet, then we can go ahead and register that. That process is simply adding it to the page hash. So that's going to be the key, which is the type, and the value, which is the page itself. And then we can go ahead and log this to the developer to let them know that they successfully registered this page. So we could say registered new page, and then in brackets, I'll log that page type. Okay, and these logs are very helpful for the developer. I would absolutely recommend doing this in your system classes, even when you develop your own systems, because it really helps you. It really helps the confidence that your system is working properly. Okay, now we also use the get page function up there, so let's go ahead and implement this function. Again, the first thing we want to do when we get pages is just see if they exist. So we'll pass that type in here. And if the page does not exist when we try to get it, we'll go ahead and log a warning. And what I'm going to say here is you are trying to get a page. I'll put that type in there. You're trying to get a page that has not been registered. Now when we actually get that page, all we're doing is returning the page from the hash with the key of type. And then here what we're doing is we're casting that object because hash tables are a generic collection. So simply using the key on the hash isn't enough. The compiler needs to know what type that object needs to be casted to. Okay. Now we've been using page exists throughout this, throughout some of these private functions here. So let's go ahead and implement that. All this is checking if the page hash contains the key of the parameter that gets passed in. So that one's really simple. Now, since we're using logs everywhere, we can go ahead and implement these log functions. So what we want to do first is see if we're actually debugging. If we're not debugging, we can just return. And then we use the built-in Unity function for logs. So we're going to say debug.log. But what we want to do is tell the developer what system this is coming from. And that's really going to help them debug whenever they have hundreds of logs coming in from their game. So we'll go ahead and prepend the log messages with the name of the system. Then I'll just copy and paste this because the only thing we're going to change for the log warning function is the actual function that we're calling within there. Okay, very good. So it looks like we've actually implemented all of our private functions except for this coroutine, which we're actually going to use in this function for turning the page off. Okay, so before we actually get to that, I want to call I want to implement this animate function here, which is in our page class. So let's go ahead and see what that's going to look like, and then we can come back and implement the TurnPage Off function. Okay, so let's go over to page. And remember, this function is going to check first if we want to use animation. Remember, we have this Boolean up here, which is a public member. If we don't use animation, then we're simply activating and deactivating the object based on this on bool. Okay, now if we are using animation, then we need to actually trigger that animation. So what we'll do is we'll say if use animation, then we're going to actually set the animator on, and I'll come back and explain exactly what this is doing. But essentially what this does is it uses the animator object to actually trigger the on state based on the parameter that comes in. But I'll go into more depth on that after we finish the page controller. Okay. Now we want to go ahead and start the coroutine for await animation since we are using animation. And remember, the await animation coroutine is responsible for updating the state. The state's going to start off as this flag on, then it will, if we're turning on, it'll start off on flag on. Then when the animation is done, we'll reset the flag to none. Okay, but the coroutine that we're starting here is await animation, and the parameter that we're passing to that is going to be the on parameter. And anytime you call a coroutine to start, you want to go ahead and stop it before, because you don't want multiple instances of a coroutine running, and except for special circumstances. Okay. So we just want to stop that coroutine before we start it in case there's an instance of that running. And that can help reduce memory leaks as well. Okay, so essentially what this is saying is if we use animation, tell the animator to start animating, use this coroutine to handle state. If we're not using animation, then all we need to do is check to see, are we turning off? So we say if not on, then we want to deactivate this object. So then we say game object dot set active false. Okay, and so we'll revisit this function after we finish the page controller, but this gives you an idea of what the page is actually responsible for, because this is the core function for this class. Okay, the core responsibility for the page is to handle the entrance and exit of itself into the view. Let's go back to the page controller. We have one more function to finish off here, or two rather. We have the TurnPage Off function and then the wait for page exit coroutine. Okay, so when we're turning the page off, we do a couple of the same things here. We're checking to see if the page exists or if the type that's coming in is equal to none or not. So we're going to do a couple of the same checks here. Now the type that we really care about whether or not it's the null enumeration is off. We don't really care about this optional parameter on. We really just care, since this function is responsible for turning a page off, we want to check to see if the off parameter is equal to none. So we'll say if off equals page type dot none, then we return. And then we want to say, we want to make sure that that page exists as well. So what I'll do is I'll actually copy this up here just to make things a little bit easier. And we're checking to see if off exists. If off does not exist, then we want to go ahead and log that warning. So instead of what we say here, we'll go ahead and say you're trying to turn a page off that has not been registered. And then everything below these two conditionals will be the actual content of this function. Okay, so what we want to do is grab the off page. So we'll say off page is equal to get page of type off. Then we say, first of all, if the off page is actually active, let's see, if the game object of the off page is actually active right now, then all we want to do is tell that to animate off. Okay. When we pass false into the animate function, that's telling the animator to animate off. And we do a quick check just to make sure that that game object is actually active before we do this. Okay, so this handles the first part of the function, the core part of the function, which is to turn the page off. But if we have these optional parameters filled out, then we need to do some work to figure out what the developer is trying to do there. So we want to say if wait for exit. So if we're waiting for the exit, then we actually want to grab the on page. So we want to say page on page is equal to get page on. And then we simply wait for the, since wait for exit is true in this instance, we want to start the coroutine, wait for page exit, and then pass the on and off pages in. And then this coroutine is going to handle what it needs to handle after that. So for the turn page off function, we've kind of done everything we need to do. So we're going to start the coroutine, wait for page exit. We're going to pass the on page and then the off page. But remember, every time we start a coroutine, we want to go ahead and stop that coroutine first, just to make sure that we don't run into any memory leaks. So we're going to stop, wait for page exit first. Okay, now if wait for exit is false, then we don't need to wait for the page to turn off before turning the next page on. So we can simply just call turn page on here. And one page can exit while the other page leaves, while the other page enters. So we'll say turn page on, and we'll pass in the on page. And that's it. So then the only other thing we have to implement is this wait for page exit. And wait for page exit is going to wait for the state. It's going to listen for the state of the off page. And when the off page state is none, which means it's not animating anymore, then we can go ahead and turn this page on. So what this is going to look like, it's pretty simple. We're just going to say while the off page, so while off.target state is equal or is not equal to page.flag none. Again, that flag none, that none state represents a state that is not animating. So while it's not equal to that, which means while it's animating on or while it's animating off, we're just going to hang in this loop for a while. So again, this while loop is saying while we're animating, we're just going to yield. Okay. And then once we break out of this while loop, all we're going to do is turn the page on. And that's it. So I think that we've implemented everything in the page controller. Now we just need to go to the page and finish some stuff up here. Okay, so on enable, there's only one thing we need to do, and that is check the integrity of the animator object. So we'll say check animator integrity. This is a private function that we defined down below. Okay, and what this is going to do is say if we chose to use animation for this page, then we want to make sure that we set the animator equal to the animator component. So the first thing we're going to do in here is say if use animation, then we simply set the animator equal to get component animator, and that grabs the animator object. Now, if the developer elects to use animation, but they forget to put the animator component on, then we need to warn them about that. So here we'll do a check. We'll say, well, after we grab the animator component, if the animator is still null, then we need to warn the developer. So we'll log a warning here. You can use whatever language you want, of course. What I'm going to say is you opted to animate a page, and then I'll pass that type in. So you opted to animate a page of type, but no animator component exists on the object. And this is just going to let the developer know that, again, the animator is not on the object that they chose to use animation on. Okay, so since we're using the log functions now, I'm going to go ahead and implement these. What I'll do actually is just copy the page controller log functions. I'll duplicate them here because they're pretty much the same. The only difference is that this is the page class, so we'll prepend that page to the log messages. Okay. So we're almost done here. All we have to do is what's almost considered the core of this class. I would say the core is really this animate function, but the animate function relies heavily on this coroutine, which is responsible for setting the target state, which is in turn going to provide useful information back to the page controller. Okay, so the first thing that we want to do is actually set the target state. So the target state is going to be dependent upon the Boolean variable that comes in as a parameter. So we'll say target state, and we'll use a ternary operator. So we'll say if on is equal to true, then the target state is equal to flag on. Otherwise, it's equal to flag off. Okay, so what this means, if you're unfamiliar with ternary operators, is it's kind of like an if conditional, where the value in front of the question mark is the conditional. So we say if on, and then the value after the question mark is then. So if on, then we return this value flag on. After the colon, it's otherwise flag off. So target state is equal to on, if on, then flag on, otherwise flag off. Okay, so I hope that makes sense. So we set the target state, then we want to wait for the animator to reach the target state, and then we want to wait for the animator to finish animating. Okay, so I'll add some comments here. The first thing we want to do is wait for the animator to reach the target state. Then we want to wait for the animator to finish animating. So it's kind of a two-step process. So what this is going to look like is we're going to use a while loop to wait. We're going to say while the animator is basically not in the current state. So that's why we use the not operator here. So what we want to say is while the animator is not in the target state. So what that looks like is animator.get current animator state info. And this parameter that I'm passing, this 0 to this function, is the layer of the animator. which if you only have one layer, you're going to be using 0. So while the current animator state info on layer 0 that is name target state, then we want to yield. So it's kind of a confusing line, but take some time to digest what this is saying. We're getting the current state info on the layer from the animator and getting the name of that state. And then we're saying if not that state. So if we're not on this target state, then we're going to yield. Okay, the next thing we want to do is wait for the animator to finish animating. So what that looks like is while mAnimator.get current animator state info. Did I spell that right? I think I did. Again, on the layer 0 dot normalized time is less than 1. Okay, so any normalized value is going to have a value typically from -1 to 1, although in this case it's value from 0 to 1. 1 being the end of that animation. So we're saying while the current animator state is not finished completing. That's what this normalized time is less than 1. So while that animation is not finished, we want to go ahead and yield. So again, these two lines are very important. Take some time to digest exactly what it is that those are saying. And then what we do is set the target state back to none. So we say target state is now equal to flag none. And then we can go ahead and say if the target state was meant to go off, so if the target state was off, that's what this indicates here. If the target state is not on, then what we want to do is go ahead and deactivate the object. So the page is responsible for deactivating itself, and we take that responsibility away from the page controller. So the page controller does not have to worry about this. So that's all we do. We just say GameObject.setActive false. Now we can also add another log statement here that will indicate to the developer when the animation finished and sort of like what state it finished on. So we can add a log statement here for that, just for more information for the developer. So we can say that the page of type finished transitioning to, now here we want to say finish transitioning to on or off, and that's going to be dependent upon this Boolean variable. So if it's on, then we want to use the on concatenation. If it's off, we want to use the off concatenation. Okay, so this is just some extra logging to help the developer understand what's going on with the page transition. So remember, back in the page controller, if we go back and revisit that, what we're doing in this wait for page exit is we're waiting for the target state to not be equal to flag none. We're waiting for the target state to become none. So here, what this while loop says is while the page is transitioning, we just want to keep yielding, and that target state gets set by this await animation coroutine. You can see we're setting the target state here, then we're waiting, and then we're setting the target state back to none. So I hope that helps you understand exactly what's going on here. At this point, we have finished the code, provided that we didn't make any typos and Unity doesn't give us any issues. We should be able to start building out the content to start testing this page controller. Now, if you are a little bit confused still, I would run this tutorial back to make sure you understand every part of this code. I've done my best to explain it, but I know that this system is actually quite complicated, and this is actually a very condensed version of the minimum requirements to get this page controller system to do what it needs to do. So take your time, go back over it if you need to, But at this point, we're going to go back to Unity and see if we can start building out some page transitions and actually see what this system does for us. Okay, so we do have some errors, which is pretty normal after we've written that much code. It's pretty hard to write that much code without having some errors. So let's just go down one by one and see what these are saying. So the name on page does not exist. Let's go ahead and double click that to see what we land on. So, right. So we actually need to define this on page before we enter that conditional. Okay, let's go back and see what else we have. So the next error that we have, cannot convert from page to page type on line 64. So we're using the on parameter here since our TurnPage on function accepts a page type and not an actual page object. Okay, which means that this function down here, this TurnPage on function call down here, needs to be taking the type instead. Okay, and I think that should take care of most of these errors. Let's see what else we have. Debug does not exist in the current context. So let's see, we should have a debug Boolean up here. So let's go ahead and add that. So this is our page class. Because we copied and pasted the log functions and we were using this debug variable, we want to make sure that we add that up at the top of our page definitions. Let's go back and see what else there is. So we're almost done here. So we have page exist. Looks like I misspelled that function. And then we have an object of type convertible to page is required. Okay. So let's look at this first one on page controller. This is supposed to be page exists. And the next error that we have is on 97. And we just need to return null since this function returns a page. Let's go back to Unity, see what we have. Okay, we look good now. So that whole process, that's just completely normal. If you write a ton of code without checking the compiler, then you're bound to have made some mistakes. It's completely normal, but we knocked some of those out pretty quickly. And now we're ready to start building the content to start testing. So I'm gonna delete some of these default assets here that Unity gives us on the project. And we're gonna start fresh with a new scene. We're gonna, let's create a folder. No, we'll just create another scene. So we'll just create a scene here and we'll call this menu since we're testing menu stuff. Okay, so now that we're in the menu scene, what I wanna do is start creating the UI. So I start by creating the canvas. I'm just going to go through some of the settings that I normally set for UI in Unity. I don't usually use constant pixel size. I use scale with screen size. And that kind of prevents you from requiring anchors as much. If you're familiar with UI, then you might understand where I'm getting at there. If you aren't, then don't worry about it. We're not going to go too in depth with how the UI system works. As long as we create the UI, everything should be good. And I'm actually going to put the page controller on this object. Let's call this object UI. I'm going to put the page controller on there, just like this. We do want to debug, so I'll check that. And we don't really want an entry page, so I'll leave that to none. Now we have this pages object, this array of objects that will end up using pages to populate. So let's go ahead and create an example page. So what I would do here is I'll right click on the UI canvas and then I'll actually create an empty object. Okay, let's double click on that to see where we're at. So I want my page to take up the entire space on the screen. So what I'll do is I'll click this little crosshair here. I'm going to hold Alt and Shift and then click this bottom right object. That's going to expand the size of the rect and the anchors to fit the full size of the screen. So again, that's Alt and Shift and the bottom right box there. Okay, I'm going to call this object my loading page, just like that. And I'm going to put the page object on this. So for some reason, the page is not getting added. Not sure why. Let's try that again. Looks like my editor may have broken, so I'm going to go ahead and restart Unity, see if that fixes things. Okay, looks like I may have just had a bug because when I reloaded Unity, I have 3 pages on here. 4 pages? Okay, so I'm just going to delete 3 of these. Maybe they were showing up and I just didn't see them. But regardless, we have the page on here, and this page is loading. I'm also going to debug this page, and I'm going to choose, for now, I'll choose not to use animation. Okay. So we have our page controller and we have our page. Let's add some graphics to the page. So I'll go ahead and add a background image. I'll do the same thing. I'll click the crosshair on the rect transform, hold Alt Shift, and make that the full width of the screen, the full height of the screen. I'm just going to call this the background, BG for background. I'm going to make this black. Then I'm going to put some text on the background. So let's create some text. I'm going to call this the header label. I'll make it a little bit bigger so it's easier to see. And then I'm just going to modify some of the settings here in the text. We're going to use a white text. We're going to use best fit. And we're going to censor the text. And then I'm just going to use the name of the actual page. So we're going to call this the loading page. Okay. And I think that's good for the content of this page. Since we're just using it to test, there's not going to be anything too fancy on here. And remember, for now, we're not going to use animation. So we want to see what happens when we don't use animation. So far, the page controller should be aware of one page. That's our loading page. So I'll go ahead and drag that into the pages array. And now we need to create our test object. So we have an object called tests. And remember the very first script that we created, which ended up outlining the requirements for this whole system, was our test menu script. I'm going to drag the page controller reference, which is the UI object, onto that test menu script. Okay, let's go ahead and recap what the test menu script actually does. So remember the things that we want to test here. Okay, we want to test being able to turn a page on, which is the loading page. We want to be able to test turning a page off. And then we want to be able to test the relationship of turning pages off and on in tandem. And there's 2 ways that we can do this. We can turn pages off and on simultaneously, or we can wait for the page to turn off before turning on the next page, which would be this test for the J key. Okay, but the first ones that we want to test here, the most basic requirements, are going to be F and G, which is just turning the loading page off and on. So we'll use F to turn the page on, G to turn the page off. Let's go back to Unity and see if this works. Okay, so I'll go ahead and just play. Hopefully we don't get any errors. And the page did start off on. Let's press G. Okay, so we press G. We got an error saying you are trying to get a page none that has not been registered. That's kind of interesting. Let's see if we can trace back where that's coming from. Page controller at 114. Let's take a look at that and see what that's talking about. So 114 from where? 96. Okay, so at some point we're getting a page, we're trying to get a page type of none. So somewhere we're trying to grab a page that's typed none. It's kind of interesting. I'll keep an eye on that, but for right now I'm not too worried. If I press F, the page comes on. If I press G, the page goes off. So that's pretty good. That's exactly what we want. Now what I typically do with a system like this is I'll turn all the pages off. So anything that's a child of my base or my parent UI class, I'll turn off if that's a page, because the system should be responsible for turning these things off and on. So I'll go ahead and play again. Curious to see if I get that warning again. And it looks like I get that warning every time I press G, which is to turn the page off. So let's take a look at that really quick. Okay, so I think I found the issue. Every time I turn a page off, I get that warning. You're trying to get a page which is none that has not been registered. So I think I found out the reason why. Before we do any sort of get page on this on page, we need to make sure that that on page is not equal to none. So I'm going to wrap all of this content in another if statement to make sure that that on page is the on type is not equal to none. So we'll say if on is not equal to page type dot none, then we can do everything here that we want to do. So I'll go back to Unity and run this function, this test function turn page off, to make sure that I'm not getting that warning anymore. Okay, so let's start this up. If I hit F, the page comes on, G, the page goes off, and I'm not getting that warning anymore, so that's really good. Okay, so there's two other test functions that we need to test. That's going to be the process of turning the page off with a page that needs to turn on afterwards. And before we do that, we probably want to implement animations, but we can try to run these tests without the animations first, and they should do the exact same thing without animations. So let's go back to Unity and create the menu page, and then we'll try to run the tests H and J. Okay, so the menu page is just going to be a duplicate of the loading page. We'll call it menu page here, but we're going to change the actual label to say menu, just so we can tell which one's which. And of course we need to change the type to menu. Okay, the next step is to actually register that. So we'll drag the menu object in here for the page controller to reference, and then let's go ahead and press play again. So I'll press F to bring in the loading page. I'll press H, which should turn off the loading page and turn on the menu page. Okay, and that seems to work. So let's run that again. Look at the objects down here under the UI object. You can see they're both deactivated. When I press F, the loading page is active. When I press H, the loading page is deactivated and the menu page is activated. Okay, but now we want some animations to prove that this is all going to work with any custom animations that we need. And what we're going to do for this tutorial, since we're running pretty long already, is we're going to use a simple fade in and fade out animation. So let's go ahead and create a folder for these animations. And inside the animations folder, I'm going to create another folder for the controllers. So what we'll have is the animation controllers in here, and then all of our animation keyframes, I suppose, inside of the animations folder, outside of the controllers folder, if that makes sense. So you'll see what I'm talking about in just a second. Let's go ahead and open up the loading page here. We want to add an animator to this. So we'll add an animator. And then we want to make sure on the page we actually select use animation. Okay, so we need to create a new controller for this. So we'll go into our controllers here, create a new animation controller, and we'll call this fade. This controller is going to be called fade, and then I'm going to drag that into my animator's controller property. And that's all we have to do for that object. Okay, now with the loading page selected, we want to find our animator window. If you don't have the animator window, you can go up here to window and find animation. You'll want to open the animator window as well as the animation window. You need both of those up. Okay, so let's go back to our page really quick. We need to recap exactly what this animation is expecting. Let's see here. Yes, so when we animate, we are setting a bool called on, okay? And that's really the only thing that matters here. And on is going to be set to true or false based on what comes into the function for animate. Okay, so true when we want to turn the page on, false when we want to turn the page off. Okay, and it's all based on this simple function call for set bool. So we need to create the bool parameter on the animator. Let's go back to Unity and do that. Okay, so from the animator, we have parameter selected, and we can add a new bool. The bool is going to be called on, and the spelling is important. It's important that the spelling of this matches what we have in the script. Okay. So what we'll do now is go to our animation tab, and actually first, let's see. Let's go ahead and right click in the animator and create our two states. Let's do that. So we're gonna have two states. We're coming from entry. We'll have the state called rest. So this will be our rest state where nothing is happening. So from rest, we can go to on, the on state. And from on, we can go to the off state. And then from there, we can kind of cycle in between on and off. To get from rest to the on state, what has to be true? The Boolean, so we have this condition. We can, okay, so let me back up a second. I don't want to go too fast here. So from rest to the on state, we can click this arrow. Okay, let me back up one more time. So what I do is I right click on the rest state. I can click make transition, and then I can click on the state that I want to go to. And that's going to create a transition property, transition relationship between those two states, rest and on. Now, if I click that transition state, that arrow, then I can actually modify what happens or what causes that transition. So with that clicked, I can deactivate has exit time. That basically means that we want to wait for the rest animation to finish before moving to the on animation. For our situation here, it doesn't, it's not needed. So we can deactivate has exit time. And now we want to set the condition. So what condition tells us to go from rest to on? When the on parameter is true, that's when we make this transition. So I hope that makes sense. Likewise, we can make a transition from on to off. We can click that transition. Again, has exit time is not important. And then we can go from on to off whenever on is false. Okay. But then we're kind of stuck in this off state. So we need a way to go back to on. So what we'll end up doing is creating a loop, control loop between off and on. So I'll right click the off state, make a transition to the on state, click that transition, deactivate has exit time, and then create another condition going from off to on, which says we can go from off to on if on is true. I hope that all makes sense. If it doesn't, just watch it again. Keep watching it until it makes sense. If this is your first time working with the animator, it can definitely take some time to set in. But this is a very simple example. So if you're having trouble understanding, just be patient and go over those steps a couple more times, and I'm sure it's going to sink in. So that's all we need for our animator controller. Although if you click on each one of these states, we don't actually have any motion or animation associated with those states. So we need to create that animation. And like I said, for this tutorial, we're going to do a very simple fade animation. So what we're going to do is click on our loading page. The easiest way to do fade is to add a canvas group, which has this alpha parameter. So watch what happens when I decrease the value of this alpha. The whole thing fades out. So I don't need to control each individual element on the page. I can use this canvas group, which is attached to the parent of the page. That alpha property is going to dictate the alpha of everything on that page. So it's very handy. So now what we can do is go to our animation. Let's see. Yeah. So we want to go to our animation and create a new animation. We might have to go to our animator and then create a new clip. Okay, so let's do this. I know there's a way to trigger this from the UI. Maybe somebody can help me out there. But what I'm going to do is go to the animations folder. I'm just going to right click and create the animation from scratch. So we can create animation here. I'm going to call this animation fade in. And I'm going to drag this onto our on state, because when we're on, that's when we want to fade in. Then I'm going to create another one called fade out. And when we're in the off state, that's when we want to trigger the fade out animation. Okay. And now what I can do is click on my scene so I can monitor how this is going to look. I click on the loading page, and then I can add the properties for my animation here. Now, a cool trick is I can just hit this record button, and now any change that I make to this object is going to be recorded as a keyframe in this animation. So I only want to change the alpha of this object. So when I'm fading in, I want to start off at 0 alpha and then approach 1. So at the 0 keyframe, I'm going to have a value of 0. And then let's go to 20 here, which is almost half a second. So at 20, I want to be at a value of 1. Now what I can do is turn off the recording mode so I don't accidentally record keyframes, and then I'm just going to hit play. And we can see in a loop fashion what this animation is going to look like. Okay, now I can hit this drop down and select fade out. This is going to be the exact reverse. So what I want to do is hit the record button. At 0, I want the value to be 1. And at 20, which again is just a little bit under half a second, I want the value to be 0. And then I can hit play to see what this is going to look like. And there you go. So our fade out and our fade in animations are done. We have the animator set up. The animator is on our page object. So at this point, we should actually be able to see the loading page fading in and out whenever we use our test F and G. So F would be turning the page on, G would be turning the page off. Let's go ahead and see if this is working for the loading page. Okay, so it actually faded in. We can also see we got this message here in our logs. Page loading, finished transitioning to on. We can also hit G. It fades off, and then we get the debug statement that says the page finished transitioning to off. So these log statements kind of provide confidence that the system is doing what it needs to do. Let's go ahead and add the animator to our menu page. So we want an animator. We can just use the fade animator controller. Everything else is set up for that. And then because the animator utilizes canvas group, we need to add that canvas group to the menu page like this. Then we want to make sure that we have use animation selected, and then we can deactivate this object and press play. So there's two things that we need to test here. That's H and J. So I'm going to turn on the loading page. I'm going to choose H. H is going to transition the loading page off and the menu page on at the same time. So let's go ahead and do that. And it was really subtle, but both of those pages transitioned at the same time. I'll restart and show you what the alternative looks like. Now with J, when we hit J, it's going to wait for the loading page to turn off completely before turning on the menu page. So let's go ahead and see what that looks like. Okay, and I hope you guys can see the difference between that. What I'll do is go to the fade. I'll go to the animator and I'll increase the time on these. To increase the time, I'll decrease the speed. So I'll decrease the speed to 1/10 of the speed and then press play. So watch what happens when I choose J. So when I choose J, again, we have to wait for the loading page to turn all the way off before turning the menu page on. So hit J. After that turns off, then the menu page turns on. And so this sort of behavior is sometimes what we want when we're designing UI, and other times we want, it doesn't really matter as much. We can turn pages off and on at the same time and make that a simultaneous operation. But that's actually going to conclude this tutorial. I know it ran pretty long, but this is a very important system. What we've done today is create a very easy way of registering new pages and providing an easy API for turning pages off and on, which is going to be very handy when we're developing games throughout the year.